This is the sample final exam, and I'm going to go ahead and explain how to work these out. Feel free to watch the whole video, or since it's kind of long, just skip to the ones that you need help with. Remember, the key for this is also posted on Blackboard, so you only really need to watch the ones where you're not understanding how to get the answer from looking at the key. So for the first one, we're going to solve the equation. It's a radical equation. So what we want to do first is try to get rid of the square root. So since the square root is by itself on the left-hand side, I can square both sides of the equation. And when I do that, the square undoes the square root. So I'm going to have x squared plus 5x equals x minus 3 squared. Remember that means x minus 3 times x minus 3. And then you're just going to distribute this out. So we'll have x squared plus 5x equals x squared minus 3x plus 9. And then we'll combine like terms. So we'll have x squared plus 5x is equal to x squared minus 6x plus 9. Now, if I take the x squared and subtract it from both sides, that's going to end up canceling out both of them. So we really don't have a quadratic equation. We have a linear equation because there's no powers on the x's that are left. So I'm going to move my x's to the left, so plus 6x to both sides. And when I do that, I'm going to get 11x is equal to 9. And then to finish solving, I'm going to divide by 11, so I will get x equals 9/11. Now, don't forget you have to check your answers. When you're solving a radical equation, you will often get solutions that don't actually work. So this is the proposed solution, but I need to check. So check this. Check. All right, so that means I need to plug in 9/11 into the original equation. So we're going to have the square root of 9/11 squared plus 5 times 9/11, all that's under the square root, equals 9/11 minus 3. Okay, so this is going to be 81 over 121 plus 45 over 11, all under the square root, is equal to, I need to have a common denominator on the right-hand side. So I'm going to multiply them both by 3. So I'll have 9/11 minus, 3 is not the common denominator, right? 11 is. Okay, so 11, I'm going to multiply them both by 11. And that makes more sense. Okay, so I'm going to have 9/11 minus 33/11. Okay, I'm going to need a common denominator over here as well, so I'd multiply by 11. So I'd have 81 over 121 plus, let's see what 45 times 11 is. 45 times 11, 495 over 121 is equal to 9 minus 33 is negative 24. Negative 24 over 11. Okay, so remember the square root. And let's say I didn't notice, I just keep working. Okay, so 81 plus 495 is 576 over 121. Okay. Let's see. So let's say I get here 576, the square root of that is 24, and the square root of 121 is 11. Okay, but remember, it's a positive. So at the very end, if I'm not paying attention, I just work it all the way out. Notice that this is not equal because one is negative and one is positive. So that means this is not a solution. That was the only option that we had. So if that one option doesn't work, that means we have no solution. Okay, so that's the answer to this problem. Now, way back here, if I saw that I had a square root equal to a negative, I could have stopped right there and said there's no solution, because whatever comes out of the square root has to be positive, can't be negative. So right there I could have known that there was no solution. But if you're just working through it, that's fine. You'll get to the end and you'll see they're not equivalent. All right, number 2. Find the x-intercepts of this equation. So remember, to find the x-intercept, you let y equal 0. Here, this is y. Okay, so we're going to set this equation equal to 0. So we'll have the square root of x squared plus 5x minus x, so plus 3 equals 0. Now, if you look at the equation that we just worked through, it's the same equation. So we're going to get the square root by itself. And when we do that, that means we're going to add x and subtract 3. So we'll have x minus 3. This is the exact same equation that we just worked out, right? And we saw that there was no solution. So if there's no solution, then there can't be any x-intercepts. So no x-intercepts. All right. Pay attention to this. This is something that they did. The people who wrote the midterm, they did this on the midterm. They gave you this exact same problems in multiple ways. And if you noticed that, then you can kind of check your work, build off of it. They did this in the sample final. Maybe they'll do it in the final exam as well. So you should be looking for that. Look and see if there are any problems that are the same or similar, so that you can kind of build on it or use previous work in that problem. That will save you some time. All right, number 3, determine the least possible degree of the polynomial function. So what you want to look at here is you want to look at the number of turning points. That's one way to kind of look at it. Another way is to look at your x-intercepts. So the turning points, let's just count the turning points. That's probably the easiest way to do it. Here's one turning point, right? It's going down and then it's going up. So 1, 2, 3. So there are 3 turning points. So the least possible degree is 4. So there are 1 less turning points than the least possible degree. So if there are 3 turning points, then the least possible degree is 4. All right, number 4, find the inverse of the function. So if you want to find the inverse of the function, what you want to do, so this is y, you want to interchange the x and the y and then resolve for y. So what we would do is we would have x equals the square root of y minus 6. And now we want to solve for y. So square both sides to get rid of the square root. So we'll have x squared is equal to y minus 6. And then we're going to simply add 6 to both sides. So we will get y equals x squared plus 6. And then if you want to write it with the inverse notation, you could say f inverse of x is equal to x squared plus 6. All right. Number 5. Okay, so this by is not really supposed to be there. So divide polynomial 5x squared plus 3x minus 2 by x plus 2. Clearly state the quotient and the remainder. So you can do this using long division, or you can do this with synthetic division. So if I was going to do it, I would use synthetic division. I just think that's easier. So remember that if you're going to use synthetic division, whatever you're dividing by, you look at the factor, and then you actually want to use the 0 to divide. So we're going to divide by -2. And then you want to make sure you have no missing terms. So you have x squared, x, and no x. So we'll have 5, 3, and -2. So we don't have any missing terms. Bring down the 5. multiply negative 2 times 5, we get negative 10, and then we're going to add straight down 3 plus a negative 10 is negative 7. Multiply negative 2 times negative 7, we get positive 14. Add straight down, negative 2 plus 14 is 12. So remember that this last one is the remainder. It says clearly state the quotient and the remainder. So the quotient is what's left other than the remainder. So that would be, since we started with an x squared, this one is going to be an x. So we're going to have 5x minus 7. So that's the quotient. And the remainder is the 12. That's what's left over, right? So there we go. Okay. And just remember on this one, they can ask you a lot of different things for the synthetic division. So here they just told you to state the quotient and the remainder. They could have also asked you, so an alternative thing I could have asked you is to find f of negative 2. Well, remember that's the remainder after you use synthetic division, so the answer to that would just be 12. So just go back and remind yourself all of the different things they could ask you for synthetic division so that you know how to answer the question. All right, number 6, find the equation of the slant asymptote for the function. So here they're only asking you for one thing. You don't have to give the horizontal asymptote or vertical asymptote. They just want the slant asymptote. So remember, if you have a slant asymptote, that means that the degree on the top is bigger than the degree on the bottom. And that is the case here because the degree of the top is 2, that's the highest exponent, and the degree of the bottom is a 1. Okay? So when you do that, what you want to do to find the slant asymptote is you use synthetic division. So we're going to divide by negative 2. Okay, again, notice that this is the same thing that they just asked us up at the top. These are the same polynomials as number 5. So you're going to do synthetic division just like we did in number 5. When we do that, you use the synthetic division and you ignore the remainder. And that's your slant asymptote. So above, we found 5x minus 7 was the quotient. That's your slant asymptote. Okay, so again, pay attention to your problems. This one clearly goes with number 5. You've already done the work. The slant asymptote is just the quotient without the remainder. All right, solve the equation. So this one, we have powers in it, right? So if we have powers in it, we usually want to get everything to the same side and set it equal to 0. So I'm going to start by subtracting 5x squared. So I will have x cubed minus 5x squared plus 3x equals 0. And now what I want to do is try to factor out any common factors. They all have an x in common. So I'm going to divide out x. So that would leave x squared minus 5x plus 3 equals 0. Now, what I would normally try to do is factor this, but if you try to factor, there's no way you can make something multiply to get 3 and add to get 5. Your only option is 1 and 3, and that does not add or subtract to get 5. So in order to solve this part, you're going to have to use another method. So quadratic formula is what pops into my head. So we're going to have x equals 0 or x squared minus 5x plus 3 equals 0. And so to solve the second equation, we're going to use the quadratic formula. So here's one answer. So keep in mind we've got to come back. Remember that that's an answer. All right. Now we're going to continue with this second equation. So we have, let's label, a is 1, b is negative 5, and c is 3. And so now we want to use that in the quadratic formula. Make sure you have this memorized. You will need it, okay? You do need to memorize all of the formulas for the final exam. So we'll have x equals the opposite of b. So since b is negative 5, the opposite of that is positive 5. Plus or minus the square root of b squared minus 4 times a times c all over 2a, so 2 times 1. Okay, so this is going to be 5 plus or minus the square root. This first term is always going to be positive because you're squaring it, so it's positive 25. And negative, we only have one negative, so it'll be negative 4 times 1 times 3 is 12, all over 2. All right, and so then we'll have 5 plus or minus the square root of 13 over 2. 13 is not going to simplify at all. We can't, reduce that radical, so that's going to be it. So remember, this is two answers. So we've got two answers here and the answer of 0 that we got earlier. Remember that this tells you the number of zeros you should expect, or the number of answers you should expect. So we found 3, so that matches with what we should expect. And so our 3 solutions are 0, 5 plus the square root of 13 over 2, and 5 minus the square root of 13 over 2. So that's the 3 solutions. And if you're doing this on your work and you clearly indicate, like how I did with a highlighter, I squared them both off, that's fine as well. Just make sure it's very easy to identify your solutions when we're grading, we don't miss something. Okay. Number 8, convert the equation to exponential form and then solve for x. So they could have just told you to solve, and you would need to know that you have to convert it to exponential form. But here they're kind of even giving you a hint on what you need to do first. And so here, remember what you want to do is you always identify the base first, and then you crisscross around the equal sign to make your equation. That's how I do it. I think it's the easiest way. So the base is 2, so you start by writing 2. It's 2 to the power of 3, because you go across the equal sign, equals, you go across the equal sign again, whatever you were taking the log of, x squared plus 5x. So that's the setup. And now you're just going to simplify and solve. So 2 cubed is 8, so that's going to be 8 equals x squared plus 5x. Notice that this is a quadratic equation, so you want to get everything to the same side of the equal sign and set it equal to 0. So I'm going to subtract 8 from both sides. So I will have x squared plus 5x minus 8 equals 0. This will not factor, so I'm going to have to use a different method. So I'm going to use the quadratic formula again. Okay. I was just checking to make sure this wasn't the same problem as above, but it's not. So A is 1, B is 5, C is negative 8. So we're just going to use the quadratic formula. So x equals the opposite of b. So since b is positive 5, it's going to be negative 5 here, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Okay, so now we're going to simplify this. So we have negative 5 plus or minus the square root of 25. There's 2 negatives here. We've got a negative here and a negative here. So those 2 negatives are going to make a plus. So plus 4 times 8 is 32, all over 2. All right, so now we're going to simplify the radical. So we'll have negative 5 plus or minus the square root of, it looks like 57, all over 2. Okay, so let's see if we can reduce the 57. So 57 divided by 3 is 19, but 3 and 19 are both prime. So this is not going to be able to be reduced. So let's make sure both of these will work. So whenever you are solving an equation with log, you want to make sure that you're taking the log of a positive number. And so we want to make sure that both of these are positive numbers. So what you want to do is use your calculator to estimate this. So we have -5 plus the square root of 57. So let's see, square root of 57. Okay. And a -5 divided by 2. Okay, so when we do -5 plus the square root of 57 over 2, we get 1.27. So that's positive, and when we plug it in, it'll be positive, but I'll show you that in a second. So now let's see, this is one option. Our second option is -5 minus square root of 57 over 2. Let's see what we get when we do that. So the square root of 57 plus -5 divided by 2, I got -6.27. Okay, so now what we want to do is make sure that we're taking the log of a positive thing. So what I want to do is plug each of these in for what we're taking the log of. So x squared plus 5x. I want to know, is that going to be positive? Okay, so if I plug in, obviously the positive is going to work. This is going to work. I need to know if this other one's going to work. So 5 times 6.27 negative is -31.35. And then 6.25 or 6.27 negative squared is 39.31. So when I subtract, I'm going to get a positive as well. So both of these work. So both of these are your solutions. Again, make sure you're taking the log of a positive number. So if you plug that in and you're taking the log of a negative or 0, that will not be a valid solution. All right, number 9. Find the vertex of the quadratic function. So the vertex you can find by completing the square and putting it into vertex form, or you can use the formula. The x value of the vertex is found by using the formula -b over 2a. Remember, b is in front of x and a is in front of x squared. So in this example, a is 3 and b is -24. So if I plug that in, I'm going to get -b, well, it's already negative, so that will be a positive 24, over 2 times 3, so 24 divided by 6, which is 4. So 4 is the x value of the vertex. Now to find the y value of the vertex, what you're going to do is you're simply going to plug in the 4 and then see what you get. Okay, so y will equal 3 times x squared, so x is 4, minus 24 times x, and again x is 4. So we will have 3 times 4 squared is 16, and 3 times 16 is 48, minus 24 times 4 is 96. And then 48 minus 96 is -48. So that's your y value. So your vertex is going to be the ordered pair for -48. Remember that you must write it as an ordered pair. If you do not, you will lose credit. So make sure you write it with the parentheses. All right, sketch the graph of the quadratic function. I'm pretty sure on your exam, when they give you a graphing problem, they will put a graph on there for you, like an ordered, like a a grid so that you don't have to draw it yourself. But here you'll just have to kind of do it yourself. I don't really know exactly what they mean by this. There could be several things that they want. What I would suggest is labeling at least 3 points. So as long as you have at least 3 points on your graph that are clearly labeled, you must include your vertex, which this one is the same problem we just found the vertex for in number 9. So you would use that work. So the vertex, what did we find it to be? 4, negative 48. Okay. So you would want to include that on your graph, which is kind of annoying because it's like way the heck down, right? But we're going to do that. So, okay, so let's say I go 1, 2, 3, 4. So here's a 4. And then I'm going to go 10, 20, 30, 40, 50. All right, so negative 50, negative 40, negative 30, etc. Okay, so I don't have to label my point on the graph because I have it labeled right at the top, right here, okay? So I'm just going to label these dashes, and then I'm going to put the dot here, okay? So that, I have it right here. So, I assume that you're going to have it at negative 48, so that's perfect. If you didn't include the numbers right here, then I wouldn't have a clue what scale you were going by, so I would not be able to give you full credit. So make sure you label your hash marks so I can clearly see where your point is. All right, and now you want to find some other points. So you can either try to find the X-Intercepts, so that'll tell you where it crosses the X-axis. So that's an option. The other option is you can just find points around your vertex. So you could plug in like 3 and 5 and find those points. That's what I would do. I would just find points. On the solution guide, when he made it, he found the y-intercepts. But you have options because it doesn't tell you that you have to find the intercepts. So what I would do is I would just let x equal 3. The reason I'm picking 3 is because I'm picking a number close to this x value. So this x value is 4, so I'm picking a 3. If the x value is 25, I would pick 24. So I'm going to pick a number that's close to that. And then I'm just going to plug that in. So I'm going to find out what is f of 3. Well, all I have to do is plug it in and find out. So that would be 927 minus 24 times 3 is 72. So 27 minus 72 is equal to negative 45. So I have a point 3, negative 45. So I'm going to go to 3 and go down to negative 45. It's somewhere right in here. Now, here's the thing. My vertex, remember you have an axis of symmetry that goes through your vertex. Oh, look, my black point is way off. See if I can erase that and move it over. So remember you have an axis of symmetry that splits your graph in half. That being said, if I move over 1 to the left and go up 3, well, I can do that this way as well. So this is over 1, up 3. This also has to be over 1, up 3. So another point would have to be here because it has to be a mirror image around the axis of symmetry. So that means I automatically know this other point. So let me do another color. Let's do green. This point has to be 5, negative 45. Okay, so now I can draw a sketch of my quadratic function. So the sketch of the parabola is that. And because this does not specify what points you need on your graph, this would be perfectly fine, granted that you have labeled your points. If you write your points down so I clearly know what they are, then this is not a problem at all. All All right. Number 11, identify any horizontal or vertical asymptotes of the function. Okay, so first of all, it doesn't tell you that you need to identify any holes or points of discontinuity, but you should do that. And so what you want to do first is see if you can factor this out and simplify it, which you can. So the numerator would factor into x plus 3, x plus 1, and the denominator would factor into x plus 3, x minus 3. And notice that the factor x plus 3 will cancel out because you have it on the top and the bottom. So since there's 1 in the numerator and the denominator, those cancel out, and you're left with x plus 1 over x minus 3. So that is kind of your simplified version of the function given. So that means that this is a point of discontinuity right here, okay? It happens at -3. So that is not going to be a vertical asymptote. The vertical asymptotes come from the denominator. So your vertical asymptotes are always all of the factors on the bottom set equal to 0, with the exception of the points of discontinuity. So the x plus 3 won't lead to a vertical asymptote, but the x minus 3 will. And so when you solve for that, you're going to add 3 to both sides. So x equals 3 is the vertical asymptote. So there's your vertical asymptote, x equals 3. Okay, so again, you find your vertical asymptotes by setting your denominator equal to 0 and solving, as long as you've already taken into account the points of discontinuity. Now you're either going to have a horizontal or a slant asymptote. You're never going to have both. And so in this case, you want to look at, well, in every case, you want to look at the degree of the top and the bottom. So here your degrees match. If you have the same degree in the numerator as you do in the denominator, that's going to give you a horizontal asymptote. And the way you find the horizontal asymptote is you look at the coefficients of the highest degree. So the coefficient of this x squared is 1, and the coefficient of this x squared is 1. So you're going to have y equals 1 over 1, which is just 1. So y equals 1 is your horizontal asymptote. And that's if the degrees match. That's what you do. All right. For number 12, it says solve the equation. So in this one, what you want to do, you have the fractions. And so I remember in class someone said their method to deal with this one is to just skip it because I had fractions. So I don't recommend that. So what I would say to do is look at all of your denominators and first make sure they're all factored. So in this case, they're all fully factored. And so what you want to do now is find the least common denominator. Remember that that includes each unique factor raised to the highest power that appears in any factor denominator. So there's no exponents on any of the factors in the denominator, so you're just going to include each different factor. So x plus 2 is a factor, x minus 2 is another factor, and it's different because it's a minus instead of a plus. And then I have the 6, which is also another factor. So I'm just going to basically multiply by all the different denominators. So what you do here is you multiply both sides of the equation by the entire LCD, and you distribute it to each fraction. So each fraction is going to be multiplied by 6, x plus 2, and x minus 2. 6, x plus 2, x minus 2. 6, x plus 2, x minus 2. And then what you're going to do is you're going to cancel out anything that's alike. So the x plus 2's cancel here, the x minus 2's cancel here, and the 6's cancel here. And so now what you're going to do is write down everything that's left. So from the first fraction, we're going to have 6. 6 times 1 is 6, and then times the x minus 2. Then on the second we have a minus, so we're going to put minus 6 times 1 is 6 times the x plus 2, which is left, equals, we have the negative 1 times, so the 6 is canceled out, but we have x plus 2 and x minus 2 both left on the right hand side. And so now we're going to distribute everything. So we'll have 6x minus 12 minus 6x minus 12 is equal to, so x plus 2 times x minus 2, I'm going to do that prior to doing this. So I'm going to wait for the end to do that. So I'm going to have negative 1 times x squared minus 2x plus 2x minus 4. So it's going to be 6, well, I guess I could simplify this side as well. So the 6x minus 6x, that's going to cancel out. So that'll leave me negative 24 is equal to, these will also cancel out, so negative x squared plus 4, because I'm distributing this negative 1 to both of those things. Okay? So now I'm going to subtract 4 from both sides. So that'll give me negative 28 is equal to negative x squared. I can multiply both sides by negative 1. So that'll be x squared is equal to 28. And now I want to take the square root of both sides. Remember to put plus or minus. So we will have x equals plus or minus the square root of 28. And then 28 can be reduced, the radical. So we'll have 28, this is 2 times 14, this is 2 times 7. So the pair of 2's comes out and the 7 remains under. So we have x equals plus or minus 2 square root of 7. And those are our solutions. Now for this one, remember that you have to check and make sure that neither of these would make the bottom 0. So you're going to plug it into the denominators. But if you look, it won't make it 0. What would make it 0 is 2 or negative 2. So if your answer was just 2, that would not work. If your answer was negative 2, that would not work. But both of these solutions will work. All right, number 13. Find the equation of an exponential function that passes through the points 0, 10, and 240. Then determine if the function is increasing or decreasing. So the first thing you need to remember is that an exponential equation is in the form y equals a times b to the x. And so these are x and y's. And so you're going to make an equation, you're going to write out an equation for each of these. So you're going to have 10 equals a times b to the 0. So that's one equation. And what happens here, remember that anything to the 0 is 1. So this becomes a 1. Well, a times 1 is just a. So that means 10 equals a. All right, in the other equation, we're going to have 40 equals a b squared. Now, we already know that a is 10, so I can plug that in here. Divide by 10. So 4 equals b squared. And then if I take the square root, I'm going to get, don't forget the plus or minus, I'm going to get b equals plus or minus 2. Okay, so now we have a choice for b. B can be 2 or b can be negative 2. But remember that when you're dealing with an exponential function, your base needs to be positive. So you really want to have that b be a positive number. So if it's going to be positive, that means it can't be negative 2. That means b must be 2 because it needs to be positive. So your function, the equation of a function, is y equals 10 times 2 to the x. Remember, the whole goal here is to find A and to find B so that you can write your equation with a number for A and a number for B and the variables X and Y. That's your whole goal. And so we've done that. The second part is determine if the function is increasing or decreasing. This function is increasing. We know that this is an increasing function because our base, b, is greater than 1. So if it was a proper fraction, then it would be a decreasing function. So for example, if we would have found that b is 1/3, then that would make it a decreasing function. But since it's greater than 1, it's an increasing function. Okay, number 14. So for this one, we want to state the domain of each of the following functions using interval notation. So what you're really looking for here are any restrictions on your domain. Meaning, is there a variable in the denominator? Because remember, the denominator cannot be 0. Is there a variable under a radical? Because if you have a square root or an even root, it can't be negative. Am I taking the log of a variable? Because if that's the case, then what I'm taking the log of has to be positive. So that's what I'm looking for. So in part A, there's no fraction, there is not a radical, and there's not a log. So there are no restrictions on what x can be. So in this case, your domain is all real numbers. That means negative infinity to infinity. You need to write it like that because it asks for it in interval notation. So that would be the answer for A. For B, there is a radical. So what I'm going to look at next is the root. This index. Is it even or odd? Well, 3 is odd. If it's odd, then there are no restrictions on the domain. If it's even, then you would have to take what's under the radical and say that has to be greater than or equal to 0. Since it's odd, there are no restrictions. So the domain is negative infinity to infinity. Okay, so this is what happens if it would have been even. So what if I had the square root of x minus 1 instead? So this is completely separate, but I just want to remind you that this is different. If it's this case, then what you do is you take what's under the radical and say that has to be greater than or equal to 0. And then you solve that. So you would add 1 to both sides. So that means x would have to be greater than or equal to 1. And so your interval notation would be 1 to infinity. That's if you have an even, right? A 2. If you have an odd, there are no restrictions. It's negative infinity to infinity. All right, part C. Notice that you have a log here. Remember that you can only take the log or the natural log of a positive number. So what you're taking the log of has to be greater than 0 because that's positive numbers. And so now you're just going to solve that. So that means 3x would have to be greater than negative 1. Divide by 3. So that means x is greater than negative 1/3. So in interval notation, that means x has to be bigger than that. So that would be negative 1/3 to infinity with parentheses. Okay. Number 15. If you invest $300 in an account that pays 4% APR compounded continuously, so that's an important part so you know which formula to use, how much will the account be worth after 5 years? So if it's compounded continuously, your formula is going to be A equals P times E to the RT. Remember, A is the amount at the end, P is the principal, E stands for a number, R is the rate, and T is the time in years. So A, that's what we're looking for. P is the principal, the original amount is 300, times E to the R, the rate as a decimal is 0.04, times t, the number of years is 5. Okay, and so all we have to do once we put that in the formula is plug that in our calculator and solve. So we have 0.04 times 5. We're going to have e to that power times 300. So I got $366.42. So $366.42. So this one really is, do you know the formula and do you know where to put all the pieces? Do you know how to use your calculator? Because that's pretty simple if you know that information. So make sure you have the formula memorized and know what all of the variables stand for. Okay, this one looks the same. It has the same information in it. The difference here is it's compounded annually. So this is a totally different formula. So if it's compounded continuously, it's the easier formula. If it's compounded annually or biannually or semi-annually or anything like that, it's going to be a more complicated formula. What this is going to be is A equals P times 1 plus R over N, close parentheses, to the NT. Okay, so A is the amount at the end, P is the principal or the original amount, R is the interest rate, N is the number of times it's compounded per year, and T is the time in years. So all of these variables are the same except the N is different here. So in the other formula you have the E. In this formula you have the 1 and the N's. So the N is how many times it's compounded in a year. This is compounded annually, so that means once per year. So N is going to be 1 in this case. So we're going to have A equals P is 300 times 1 plus R, the rate as a decimal is 0.04, divided by N, which is 1, to the power of N times T. All right, and now all we have to do is put that in our calculator. So we have 1 plus 0.04. Okay, and then that's going to be raised to the 5th power. And you're going to multiply by 300. And so for this one, I got $364 and, well, if I'm writing near a cent, it should be $365 even. Because, so let me write down what I have on my calculator. 364.99587. So this 5 is going to round this up. So this should be $365 exactly. Okay? So I know the key had $364.99, but it really should be $365. Okay. Okay. So 17. Convert the following exponential equations to logarithmic form. So all you have to do is rewrite these. The first thing you want to do when you're doing that is you want to identify the base. So I'm going to go through and highlight the base. And remember, the base is easy to find. It's what's raised to the power. Once you know the base, you're just going to have that be the base of the logarithm. So you're going to write log base 3, and then you go across the equal sign of 9 equals 2. It's that simple, and that's it. That's your answer. That's all you're doing. Remember, for part B, you really want to use the natural log because you have the e there. So you would write the natural log of e of 1 is equal to 0. Okay, and then this one, you would say the log base 2 of 8 is equal to 3. And that's it. Now, on part B, you really don't have to write the e because the base is understood to be an e. So really you can rewrite this as natural log of 1 is equal to 0. I wrote the e to make sure you see where that goes, but you don't have to write the e because it's understood. But that's all for that. So just make sure you know how to convert from one form to another. All right, number 18. So on day 5 of the COVID crisis, Transylvania had 12 COVID cases. So really these could be looked at as an ordered pair. So days, number of COVID cases. On day 10, they have 62 COVID cases. So here's another ordered pair. Suppose that the number of COVID cases is growing exponentially. So there's a key word here. Give a formula for the number of COVID cases on day X. So this is like the problem that we did earlier where we're finding a formula given 2 points. So this is just like number 13. It's just in a word problem format. Same exact thing. So what we're going to do is we're going to make an equation, that's the exponential equation, associated with each of these ordered pairs and try to solve for A and B. So we have y, let's plug in something for y. So 12 is equal to A times B to the 5th. Now in the other one, it worked out really well where the B was raised to the 0, so that just disappeared and voila, we had A. This one's not that easy. So we're going to have to solve, let's say we solve for A. So what I could do is divide by B to the 5th. That way I can get A. And it'll be in terms of B, but that's okay. So A is equal to 12 over B to the 5th. All right, so there's A. Now I want to make another equation with the other ordered pair. So it will be 62 is equal to A times B to the 10th. And what I can do is I can substitute this A with the 12 over B to the 5th, because that's what A is. So I will have 62 is equal to 12 over B to the 5th times B to the 10th. All right? And so now that will simplify into B to the 5th up here, so that would be 12 times B to the 5th. Okay, so now I want to solve for B. So first I'm going to divide both sides by 12. So if I divide by 12, I will get, say I can reduce this to 31 over 6 is B to the 5th. And then I can take the 5th root of both sides. And since it's an odd, I don't have to put plus or minus. So that's going to be B is equal to the 5th root of 31 over 6. So now that I know what B is, and I have a number for that, I need to go find what A is without a B. So now I have to plug this in for B. Okay? So I'm going to have, let's do this in blue. I'm going to have A equals 12 over B to the 5th. Notice I had right here 31 over 6 is equal to B to the 5th before I took the 5th root. B to the 5th then is defined as 31 over 6. That means I can plug 31 over 6 in for B to the 5th. That means I'll have 12 over 31 over 6. Okay, remember that a fraction bar is the same as a division sign. So this is the same as 12 divided by 31 over 6. You can change this to multiplication and flip it. So this would be 12 times 6 over 31. And so then you can multiply straight across. So all of this is equal to A. So let's see, 12 times 6 is 72 over 31. So that's A. So A is 72 over 31. So this is A. All right, so now we have a number for A. We have a number for B. And so we're going to use those numbers to write our equation. So we have y equals 72 over 31 times the fifth root of 31 over 6 to the x power. And that would be our exponential equation for the growing COVID cases. So while this one is just like number 13, it's much more difficult than the other one because of the numbers given. But it's the same process. Okay, number 19. A water heater has heated water to 140 degrees. The temperature of the surrounding air is 75 degrees. Use Newton's law of cooling with K equals negative 0.5596 to find the temperature of the water after 5 minutes. All right, so this one, you're just going to use the formula that was given, and then you're going to plug it in your calculator, okay? So make sure you just are careful here. The TS is 75, so this is going to be 75 plus T sub 0 is 140 minus TS is 75 times e to the KT. K is negative 0.5596 times T is 5. And so they gave you everything you need. All you have to do is plug that in your calculator. So to me, this one looks extremely overwhelming. If you're just looking at the formula, it looks like a lot. But if you carefully look at it, they've given you all the information. So it's just a matter of knowing how to use your calculator at this point. So let's see what we get when we plug it in our calculator. So when I plugged this in my calculator, I got 78.96 degrees. Now, in this one, it didn't tell you what to round it to. Since both of the temperatures were given in whole degrees, I think it would be reasonable to put 79 degrees. But if you wrote 78.96, that's fine as well. Just make sure that you round appropriately. All right, number 20. Solve the equation. So here, what we want to do is try to get rid of the log so we can get the x by itself. So let's see. First thing we probably want to do is get the log by itself. Whoops. So we're going to divide both sides by 3. So that'll give us the log base 5 of x plus 1 is equal to 2/3. At this point, we can rewrite this in exponential form. So we want to first identify the base. The base is 5. So this would be 5 to the 2/3 power is equal to x plus 1. And then at this point, you could subtract 1 from both sides. And so x equals 5 to the 2/3 minus 1. Now, 5 to the 2/3 power, that's not going to, work out evenly. So you can just leave it like that. That would be fine. That's an exact answer. So I guess I want to also say on this one, if you're not sure, what you're doing, it's okay to show as much work as possible. So even if this doesn't look right to you, you can put it in your calculator and get an estimation. You can leave it like this, but just show as much work as possible so that you can at least try to get some partial credit. Okay, number 21. So an account with an initial deposit of $6,500 earns 7.2% annual interest, compounded continuously. So again, I always try to look for this when I'm reading this problem because that's kind of the key word. Keywords to let me know which formula I'm using. So since it's compounded continuously, I know it's going to be this formula with the E. So A equals PE to the RT. Now I'm going to keep going. How long will it take for the account to be worth $7,000? All right. So I'm asked here how long. So that means I'm not going to know the time. So t is going to be the variable that's left when I plug in the information. So an account with an initial deposit of $6,500. So $6,500 is the P. Okay. It wants to know how long it'll take for the account to be worth $7,000. So that's going to be the amount at the end. The rate is 7.2. As a decimal, that's 0.072. Remember, you move the decimal over to the left twice. And then t is what we don't know. And so when you have it like this, your exponent has the variable in it. You're going to have to solve for that. So you always do the same thing. The first thing you do is try to get rid of what's in front of the e. So we're going to divide by 6,500. So now I'm going to have e to the 0.072t is equal to 7,000 over 6,500. Now, to get rid of the e, I'm going to take the natural log of both sides. So the natural log. Okay, and then I can bring down what's here in front of the natural log. So I'm going to have 0.072t times the natural log of e is equal to the natural log of 7,000 over 6,500. Remember that the natural log of e, since the base is e and that matches, that's 1. Okay, anything times 1 is itself. So we're going to have 0.072t is equal to the natural log of 7,000 over 6,500. And then to finish solving for t, we just divide by 0.072. All right? So t is equal to that. So if you want an exact answer, you can put that down. The natural log of 7,000 divided by 6,500 all over 0.072. More than likely, they're going to want you to put that in your calculator. So when you do that, I get t is equal to 1.03 if I round years. Okay. Number 22. Solve the equation. Okay, so here, notice we have the natural log on both sides. When you have something like this, your goal is to get one natural log on each side. And so if you remember, if you have the sum of two logs, you can change this into a product of one log. So this can be rewritten as the natural log of 2x plus 9 is equal to the natural log of 5 times x. So you end up multiplying this times this, and it's one log. Now that you have a log on each side of the equal sign, those just kind of undo each other. So you can rewrite this equation without the logs. Without the natural logs. So you get 2x plus 9 is equal to 5x. And now this is simple to solve. You first you subtract. So you get 9 equals 3x. You divide by 3. So x equals 3. All right, now you want to make sure you plug this in to ensure that you're taking the log of a positive number. So if you plug it in here, you're taking the natural log of 3. That's fine. If you plug it in here, you're going to have 2 times 3 plus 9. So it's 6 plus 9, which is 15. That's a positive number. That's fine. So this is fine. So this is your solution. Okay. Number 23. Use the rational zero theorem to list all possible rational zeros. So it's not asking you to find them. You just have to find the possibilities. This is very simple. So don't skip this one. Make sure you know how to do this. what you want to do is you want to find all the p's over q's. So remember, your very last number, your constant, is p, and the number in front of your leading term, so your leading coefficient, is q, and you're going to find the factors of those numbers. So the factors of 2 are 1 and 2. That's what multiplies to get 2. The factors of 8 are 1 and 8 and 2 and 4. That is what multiplies to get 8. And so now all you do is you make all of the possible fractions of p over q. So your possibilities are plus or minus every p over every q. So I'm going to start with 1. So it'll be 1 over 1, 1 over 2. So 1 over 1 and 1 over 2. Okay, now I'm going to do 2. 2 over 1 is 2, and 2 over 2 is 1. Okay, so I need to start trying to reduce this. So let me rewrite this list. So plus or minus, 1 over 1 is 1, 1/2, 2. 2 over 2 is 1. So that's just going to be 1, which is already on the list. Okay, now I need to use the 4. So let's see, I've used the 1, I've used the 2. 4 over 1 is 4, so that's different. I'm going to put that down. 4 over 2, that's 2. Well, that's already on the list, so I don't need to write it again. Okay, now I've used the 4, so now I need to use the 8. 8 over 1 and 8 over 2. Okay, 8 over 1 is 8, that's new. 8 over 2 is 4, that's already on the list. And now I've used all of the p's over all of the q's. So here is my list of possible rational zeros. And that's it. That's all you have to do. You don't actually have to find which ones work. They just want the list of possibilities. All right, 24. Find an equation for the quadratic function f of x graphed below. Okay, I'm going to need some more space to write here. I'm just going to move it here. I have all the information I need. Well, I need that. Okay, so what you want to do here is first you want to identify the vertex. So the vertex is here. That is at 2, -4. So there's the vertex. Okay, and then you really want to have a clear other point. If you look here, you can see that the y-intercept is 0, 2, so we're going to use that as well. And so here is what you're going to do. Your equation is y equals a times x minus h squared plus k. So h and k are the vertex, so you need to remember this. H and k are the vertex. A is just some factor that could be there, but you have to solve for that. And then x and y you're going to use your other point for. So y is 2, a is what you're trying to find, x is 0, minus h is 2, and k is 4, or -4. K is -4. And now we're going to solve for a. So 2 is equal to a times 0 minus 2 is -2. -2 squared is 4, minus 4. We're going to add 4 to both sides. Okay, so now we get 6 equals 4a. We're going to divide by 4, and then we're going to reduce that fraction. So a will be 3/2. Okay, so now that's all we really needed to find is the a to write our equation since we have our vertex. So we have y equals 3/2 x minus 2 squared minus 4. So in order to write your equation, this is your answer, you need to have the vertex and another point so that you can solve for a. Once you have a, you're going to use A and the vertex to write your equation. And that is the answer. All right, 25. The population of a pod of bottlenose dolphins is modeled by the function a of t is equal to 9 times 1.16 to the t, where t is given in years. To the nearest whole number, what will the pod population be after 3 years? Do not overthink this one. This is so simple. 3 is t. They just want you to plug that in and put it in your calculator. So a of 3, because it's 3 years, is equal to 9 times 1.16 to the 3. You just have to know how to use your calculator. So 1.16 cubed times 9. So I got 14.05. So we can round to 14 because it's dolphins, right? You're not going to have 0.05 of a dolphin. So we'll say 14 dolphins. And that's it. All right. And number 26. So it's the last one. Identify the location of all of the zeros of the polynomial. Then determine if the multiplicity of the zero is even or odd. So this is a little bit different than what we talked about in class. But let me just explain what it means. This one's pretty easy, so I don't want you to lose points on this one. The dark, thicker line is what we're looking at. And so we're looking for the zeros, which is where it crosses the x-axis. So that happens at 3 places. Okay, so there are the zeros. So if you're asked to identify them, all you're going to do is highlight or circle where that crosses the x-axis. That would be fine. Then determine if the multiplicity of the zero is even or odd. So remember, if it goes straight through, it's a multiplicity of 1. So this would be a multiplicity of 1 because it goes straight through. Well, 1 is odd. So this would be odd, an odd multiplicity. Okay? If it bounces back, like in this example, the second one, it bounces back, this represents a multiplicity of 2. Well, 2 is even, so you would say that this is even. And then if it wiggles, like in this third case, this represents a multiplicity of 3, so this is going to be odd. So if you remember in class, I said technically this could be, like this second one, could be any multiplicity of 2, or in even. It could be 2, 4, 6, etc. We usually just say it's a multiplicity of 2 because we're talking about the least possible degree. So that's kind of why it's asking if it's an even or odd multiplicity. So that's what you would do. Just determine, like we did in class, multiplicity 1, 2, or 3. And then if the number is even, you say even. If the number is odd, you say odd. And that's all there is to this one. If you have any questions after watching this, please let me know. I hope you have a great afternoon.